Today we're going to be discussing solar power monitoring technology that allows you to see the status of energy being generated by solar power and how solar power monitoring systems work. If you have any questions at any time, please enter them into the chat box. I'm Maria Lamoni, Sales Manager here at ICP-DAS USA. We'll go over solar power technology, a clean renewable energy, different kinds of hardware and software that gather and display solar energy production information, software that logs data, displays trend graphs, sends email and text message alerts based on information, and devices that help with communication. Photovoltaic PV cells convert sunlight directly into electricity. The DC direct current electricity is converted into AC alternating current for powering devices current with inverters. Current input boards and DC input modules help with monitoring the energy generated by solar panels. ICP-DAS USA provides industrial-grade control and monitoring solutions, including data acquisition, data communication, control, wireless, and touchscreen equipment. We also provide SCADA and control and monitoring software. We provide free technical support and provide programming services and training classes out of our office in Lomita, California, near Los Angeles. We provide free programming services for very small and large projects. We are the USA office and support North and South Americas. We have offices around the world and our products are used worldwide. Solar power is used for powering many applications like freeway lighting, freeway call boxes, powering homes and buildings, satellites, control panels, remote monitoring systems, and even some cars. Photovoltaic PV cells are made of semiconductors like silicon and have been used to power satellites since 1958. PV cells convert sunlight directly into electricity. They allow photons, or particles of light, to break free from electrons, which generates a flow of DC direct current type electricity. The inverter changes the DC electricity into AC electricity, which is sent to electrical panels or breaker boxes on buildings to power equipment, including appliances, devices, and lights. A utility meter is connected to breaker boxes for measuring energy consumption. Excess solar energy is put into the electricity grid or energy storage units for using at night or when the sun isn't shining. The cost of solar panels has been decreasing rapidly. Advancements in solar technology have allowed for screen-printed solar cells, resulting in solar home siding, solar roof shingles, and other solar materials, so regular everyday materials that are normally exposed to sunlight can now take sun power and turn it into energy. Solar power monitoring systems track energy production by solar panels and send email and text message alerts based on production information for optimal performance. Repair personnel can service panel systems as necessary to keep energy production consistent. Solar power energy can be sold back to utility companies, so any decrease in production means decrease in revenue, and monitoring systems can help to ensure profit losses are kept to a minimum. Data is logged for analysis and can be used to show trending information of energy production rates over time. Declining energy production information indicates the panels need to be washed or serviced. Reports are sent out by email on a weekly basis and include a list of all alarm events, a graph of weekly, monthly, and annual energy production data. Temperature, humidity, and light sensor information is also collected and provided in the reports. The system is accessible from a remote location through a web browser. Fiber switches provide EMS, electromagnetic static protection. Cellular wireless data servers pass back Modbus data to remote SCADA systems. Current input boards with clip-on current transformers monitor the current from the solar panels. They take in AC input and put out a DC voltage for monitoring energy produced by solar panels. DC input modules take the current from the board and pass it on to SCADA control and monitoring systems, which displays and manipulates the information. Fiber and switches and cellular device servers help to pass the information back to other systems. analog input modules, which take the DC voltage from the solar inverters, provide information to the SCADA system. You can also use vibration sensors with these type of devices to test the vibrations out at the field. You can also use them to test wind, humidity, temperatures, and other kinds of information. Wireless versions are also available. The products are DIN rail mountable and can mount right into the control panel, and they survive in harsh conditions, so they can survive in very cold or very hot desert or mountain type environments. SCADA software can be used to display the information and shows the generated energy data. You can also see different documents like data logs, reports, email alarms, email status updates. You can also view the system from a web browser, and you can see trend graphs. Robert from our technical support department is going to show you the demo in a few minutes. Our equipment can be powered by 10 to 30 VDC, so you can power it directly with the 12 VDC from the solar panel. This is a C-language programmable controller that can be connected to your solar remote monitoring systems for passing the data back to a SCADA system over the cellular network. For energy monitoring, you can also use power meters to monitor energy device consumption, and you can pass the data back to the same or to a different SCADA system. Touchscreen PLCs can be used to show the information at the solar panel inverter site or in another location. They're programmable in C language and ladder logic, and they have a lot of different communication port connectivity like USB ports, serial ports. They can be powered, some of them can be powered over Ethernet, and some of them have a real-time clock for scheduling operations. GT540 can be used for remote monitoring, so you can pass back different kinds of information like temperature, tank level, earthquake activity, or solar panel energy production information over the cellular network. Now I'm going to pass the presentation over to Robert, who's going to give a demonstration of control and monitoring systems for solar power.
Thank you, Maria. Let's see, my name is Robert Morrell. I'm in the Technical Support Department. Today I want to just show you our Indusoft demo program and show you some of the features of Indusoft that can be used for in your SCADA application for the solar monitoring or for almost any industry out there. Let's see, these modules work very well, or I'm sorry, the SCADA program works very well with most industrial protocols, including Modbus RTU, Modbus TCP, Ethernet IP, and a GPRS or OPC. Right now, let's see, I'm going to show you the wind energy demo. This is probably closest to the solar energy monitoring system that is included in this demo. As you can see, you can do many different features. I'll go over some of them in a minute. But this SCADA software is used to graphically show and data log the status of, in this case, the wind turbines, but in a solar application, it'd be like the battery voltages and the power generated. There's other industry demos. This one shows the oil and gas industry. This one shows automotive, the food and beverage, wastewater. Most of these graphics and animations can be created on your own, or you can use images which are pre-existing in the Indusoft library of images. And if you need some objects for a different industry, please feel free to request it from us. There may actually be some other libraries that we have certain images or animations from that we can send you. Let's see, for the features, you could do many different features like bar graphs, color changes, text images where you can actually see the numerical value of an analog input or output. So you could do rotation, resizing, position, commands, active objects. Click on this, such as combo boxes, radio buttons, checkboxes. These are used for selecting and deselecting things. You could also use ActiveX controls to show, in this example, an IP camera. You can create recipes for doing certain parts of your application. Report generation, this is an important aspect of SCADA. You use the data acquired from your modules, log them in a database, and you can create reports using Indusoft and export the data or share the data with like a SQL database or other people. You can send out email reports as well. You can create remote or connect remotely and view the data through like a web server. Trend curves, another aspect of SCADA that's very useful. You can create a nice trend showing the status of your I/O points, and if you see an alarm or something, it can be indicated on the screen. And let's see, we also have alarm window, which you can use scripting to send out, say, email alarms, text message alarms, show a visual indication, or have a window like this where you can acknowledge alarms and show them your application. Let's see, the idea behind this is you create a nice picture and animation to describe or to display your project, and then visually use the objects within Indusoft to show the statuses, display trend curves, send alarms, and many other features. Does anyone have any questions? Otherwise, we can go through a few of the other examples. Here's a little bit of information about Indusoft. Indusoft was started in 1997 and was designed for embedded systems, but you can also use it on PC or Windows CE or Windows XP embedded type systems.
If you have any questions, just type them into the chat box. Okay, I guess if there's no questions, thank you so much for coming to our training on solar power monitoring systems. If we can help you with any projects, please feel free to contact us anytime and hope to hear from you. Thank you very much. Bye-bye.